Hello guys, welcome to the new video again. And in this video we will discuss derived operators and digital logic. So what are derived operators? Right. So to table. So how many? What was our derived operators was? First one was NAND, and second was NOR. Third was XOR and implication, and fourth one was equivalent, and we can say X NOR also. Here, double what we said that biconditional. Right? This is called biconditional. Right. So let's say there are two variables P and Q. Which variables are there? These preposition variables we can say. So possible combination would be false, false, and false and true, true and false, and true and true. So in this, what we will do is this is truth table, all right? Truth table. So first one would be NAND gate, right? So in this NAND gate, this is similar like Boolean algebra, all right? Similar like same as we can say same as Boolean algebra, NAND gate. So false and false would be fa false and false. Be false. What is written in NAND? So it will be true, true, false, true, false, true and false is false. True and false is true, true and true is false here, right? Next would be nor. Nor is implication or is nor, right? So nor would be true, true, false, false is not true. Now it would be what? It would be false here. Like that, all right? And third would be what? XOR. XOR is like in XOR, the sign of XOR is this, and when both variables are similar, then it is false. If they are different, then it is true. So XOR would be like this: false. P and Q is true, true, and now false. Alright. So this operator is important here. Implication. So let me highlight this with different color. Implication. An implication. False implies false is true always. False implies true is also true, and true implies true is also true. But when true implies false is false. So this case is very important. Okay. This case is very important here for implication. This case, right? True to false. True implication false is false always. And next is our biconditional. This biconditional when true and false in false. False is when similar it is true. When different is false. False and true. It work as XNOR. Right? So we have to focus on this. Uh, we have to focus more on this operator, implication operator, in further videos. Right? This is important gate from gate perspective. So let's see. Properties is so let's discuss properties of why was it? If we want to convert implication in Boolean algebra, we can convert it like that. Formula. It would be like that. T, we can say P implies Q equivalent to P complement plus Q. Right? So this is Boolean algebra of all right. So there are some notes are therefore implication properties. Properties is like this. XOR is equivalent to finding differences between operands or prepositions, and XNOR is equivalent to finding similarities between operands or prepositions. Alright, so this is how we do it. Alright, P plus PH or Qs. So some more properties are also there. One is P plus Q is P XOR Q is C differences between P and Q equivalent to P C differences between P complement and Q complement also, right? But P complement XOR Q equivalent to C similarities between P and Q P XOR Q dash equal to P XOR Q, right? Right. This is like that, all right? So this is equivalent to finding similarities. Is between P and Q, right? And second would be P XOR Q is find similarities between P and Q, and next is but P complement XOR Q is find differences between P and Q is equivalent to P XOR Q. So let me discuss more with help of chat GPT, or we can say AI. What is the focus of this? Just take a moment here. Why P XOR Q is equivalent to finding differences between P and Q in discrete logic. So we can explain it more from there. Exclusive X or denotes as P as Q, or sometimes Q is equivalent to finding difference between P and Q, because it is true if and only if P and Q has different values. This operation yields true when exactly one of the propositions is true and other is false, which exactly highlights the difference between of two. So it is only true when it is right. This is how we do it. So there was no much here. Was we were confused. So this is now clear. More properties would be like this. Let's discuss more properties here. Commutative property. Commutative is also here. So P, what is this? NAND? Is it NAND? Yeah. NAND Q equivalent to Q NAND P. It follows commutative. P nor Q is equivalent to Q nor P. So it follows also commutative. P XOR Q equivalent to Q XOR P. It also follows commutative law. Right? But P XOR Q is not uh, is equivalent to Q is P. It is not true, because when P is, let's say P is true and Q is false, then true implies false is false, but when false implies true is true. So this is not equivalent. It is, they are contradictory to themselves. But uh, biconditional would be like that: P Q equivalent to Q to P. Alright, guys, wait for a minute. I am coming. This is equivalent. Alright. Thank you so much, guys. Let's discuss more properties. Not all. So next is associative. So R is equal to. So associative law, X NAND follows associative law. It is true, yes. No. To prove them easily we use Boolean. These are some properties we can use to prove them. We can use Boolean algebra easily, right? And truth tables, right? So we can prove them. And px p nor q nor r is equal to p. It is also true, but p xor q xor r is equivalent to p xor q or r. This is true, and p implies q implies r is p implies q implies r. This is not true. So implication does not hold. Implication does not hold. देख क्या हाँ associative law. Example implication is distributive over or some. This is question. Question 1 is implication operator is distributive over, or let's say let's say this is the example. Is it equivalent to p implies q or implies r? Let's say in this p plus q or r, p plus q or p y plus r. This is plus only, and py plus q plus r equivalent to py plus q plus r. These are both equivalent to each other, so it is true. Yes, we can say yes. Yes, implication is distributive over or operator. Right. next we will discuss something. For that thing, wait for 5 minutes.